Hello everyone, can you hear me? Anyone? Can you confirm?
Yes, sir.
Okay, so we'll wait for a few more minutes for the others to join, then we'll start. So I can see some new people here who was not there in the last class. So in last class we solved the previous year assignment, like similar to the first assignment. So mostly we will be doing the same thing today also, like every day we'll be solving some previous year assignment so that you can solve this year assignment also. Before starting that, I want you to tell me about yourself, like whoever is the new, like what are you studying right now, and what background you have and all. Can you start, like whoever is new here? I think Shomik Pandey. Are you are, can you hear me? Hello.
Yes, sir. Yes, sir.
Yeah. Can you introduce yourself? Like what are you studying? Where are you from?
Yes, sir. I am Shomik Pandey. I am a senior research fellow from the University of West Bengal State University,
Okay.
and I am working on mathematical modeling in like as mathematical ecology and some delay-based mathematical model. So
Okay.
I am
Okay. Okay.
here
Nice.
to.
Sure, you are a senior research fellow. I see.
Yes,
So,
yes, yes.
for the new people, I will introduce myself first. So, my name is Sahil Islam. I am working. I am also a senior research fellow in Department of Physics in Institute of Technology, Hyderabad. I am a student of physics, actually, not a mathematics background student. I work in mathematical modeling in biological system and motivated by physics stuff. So I'm doing this TA where these things like mathematical modeling stuff is also new to me in a mathematics point of view. So the whole point of this conversation, these sessions will be to learn stuff together. Like it wouldn't be like I am going to solve with the assignments in front of you and you will be like attending it and moving on. Those who were here last week, they all know that this will be an interactive session. You will be solving and along with me, and you have to interact. Okay, so you'll be like unmute yourself and answer. If you are not comfortable with that, you can write in the chat also. Okay, so who's next? I think this Kalai Selvi Anandan is new also. Are you here? Okay, Kirtika, I think she is here. Priyadarshini, you are also new, right? Hello. Yeah, hi. Can you tell Kalai Selvi, yeah, can you tell me like what you studying, which background are you from in the chat maybe? Meanwhile, Priyadarshini, you can if you can unmute. You're doing a masters in math, okay. Sakina, are you here? I don't think. Good afternoon. Can you tell me about yourself? Okay, take your time. And okay, fine. Just I am pursuing PG degree in maths. Okay, so you are all are mathematics student. We had some BTech students last week and some assistant professors also. I don't see all of them. Shuma Ghosh was here in the last week, but I think she joined late. Shuma, are you here? Okay, fine. Anyway, whenever you're comfortable, just keep interacting. You have to answer and you have to actually do the problems. So you should get ready with pen and paper. So let's start. So assignment 2, you guys did get the this year's assignment 2, right?
Yes, sir.
Yes, yes.
Yes, yes.
Okay, so if you go through that, you will see that this assignment is a previous year assignment. You will find that both are quite similar questions, but not exactly same. So let's start. So with question 1, what is the physical meaning of linearly varying survival function S equals C? Which is contest competition, scramble competition, only few people fight for resources, there is no competition. So who will tell me what contest competition is? Will you go through the lectures?
Contest competition.
Yes, contest competition. What is contest competition? You can raise hands if you want to say, or you can just unmute. So these are,
I'm sorry, sir.
yeah,
I'm sorry, sir. Basically, I'm not completed the session till now.
okay,
So I am sorry, extremely sorry.
fine. So see, there is you don't have to be sorry. It's just you should tell me what's there. Okay. So if you know, you tell it. If you don't know, no problem. Don't be shy or embarrassed or anything. There is nothing to be embarrassed about. So anyone in this group can tell me what is contest competition or what is scramble competition? So what is survival function? What is survival function? Do you remember any kind of this kind of equation? This kind of equation? Do you know about these equations? Anyone, you can raise your hand, or you can say no also, no problem. Okay, I assume you don't know about this kind of equations. Okay. In contest competition, we have finite number which the cells are able to take resource. Number of resources cells are able to take one resource will survive and take part in next generation. In contest competition, we have finite number of resources. Yes, and what is scramble? Venkatanathan. So since you are interacting, you can see the screen, right? Anyone just tell me you can see the screen or not?
Yes, yes, it is visible.
Okay. So uh, where to start? So in scramble competition, each individual is assumed to share equal amount of limited resource. Exactly. So what will be this answer? Since you are saying answering, what do you think this answer of this? What kind of function is this?
Contest competition.
Who answered right now? Someone saying contest competition. And can you tell me why you think it is contest competition? Hi, Deepinder has just joined. Okay.
Hello, good afternoon, everyone.
Yeah, good afternoon. So we just started. We are still in question 1, as you can see. So who was answering about contest competition? So in simple terms, contest means when there is a contest, and scramble means where there is no contest. Contest means so they have to fight for the survival. So the resource is limited, and if the resource gets crosses a particular critical resource, particular critical concentration, they wouldn't survive equally. But in scramble competition, cells So in scramble competition, every individual will have equal opportunity. Okay. So in that context, if survival function is proportional to c means the concentration of the species. So if it is proportional to c, what does it make it? Does sir, it is a contest competition. In contest competition, is c critical by c? Yes, Venkatnathan is saying that in contest competition, if you go through the lectures, you will see SC is written for as C critical by C, for C critical greater than C, or 1 for C critical less than C. What does it mean? So it means survival function will be 1, that is always like it's, you can think of it like 100% probability if critical is less than C, or no, sorry, it will be the opposite. Is it correct? What I am writing is correct or not? Which one was correct? So what I was saying that if SC is proportional to C, that means all the individuals are not sharing, all the individuals are not having equal opportunity to survive. Based on the C, it is changing. But if it was a scramble competition, then it will have, everyone will have the equal opportunity of survival. Okay, so this SC equals C will be a contest competition. Okay, or any question? Fine by everyone?
Yes.
Okay. So when there is no competition at all?
When the sources are readily available.
Sources are readily available, yes. Like everyone has this same kind of like 100% probability of survival. Okay, so let's me go to question number 2. This is an easy question. You don't have to think too much about. This is not even a modeling question. It's some function question. So, what is the nature of the graph SC equals 1 by 1 plus c square? So, math student here, can you tell me the answer? There are lots of math student here. Don't think about it as a math modeling question or any. You don't have to go through the lectures to answer this question. So Venkatnathan is saying that monotonically decreasing as c approaches to infinity. So what is c approaches to infinity? What happens to this function? So someone else, do you agree with him, Shomik? Are you here?
Yes, sir.
So
It is monotonically decreasing also.
Monotonically decreasing and converging to 0. Why? Because if you go as to c tends to infinity limit, what happens? The denominator diverges, right? So
Yes,
this
yes.
will go to 0. So that is monotonically decreasing and converging to 0. Now there are two options. One is monotonically decreasing and converging to 0, but decreasing but not monotonically decreasing. So what are the difference? Who will tell me this? What is monotone decrease? Monotonically increase or decrease? So who will tell me the difference between monotonic and non-monotonic functions? I heard a lot of maths MSc students here. So these things you will be knowing better than me, I guess. I'm a physics student, as I told you. What is monotonically decreasing? Decreasing means the function decreases for each input value. Okay. Venkatnathan is saying that monotonically decreasing means the function decreases for each input value. It is not the like fully correct. There are flaws in the answer, but I understand what you are trying to say, Venkatnathan. Anyone? Kirtika, are you here? This Tamarai Maths, are you here? Don't feel shy. If you don't know, just say don't know. No one will judge you. Vijay Lakshmi, are you here? Fine. Priyadarshini, Shomik, Tejinder, do you know? Hello? I feel like I'm not audible or anything.
When x1 is less than equal to x2, we can say f of x1 is also less than equal to x2.
Exactly.
That kind of a function.
Exactly.
Yes.
And for all x1 and x2. So monotonically decreasing function f has a condition f a greater than for optimal output value is lesser than. Yeah, like what Tejinder and Venkatnathan is saying that if suppose if f of x, so how do you check? So for x1 greater than x2, if x1 f of x1 is also greater than f of x2, then for every increase in x, function is also increasing. Similarly for decrease in x. So for a graphical point of view, suppose I am plotting x and fx. Okay. So there is a function like this, and there is a function like this. What is the difference between these two? Which one is monotone and which is non-monotone? Suppose this is f1, this is f2. So if you look at it, for x increase in x, eventually both the function decreases. But for if you pick any slice here, pick any slice like this. Here you see for f1 with increase in x, function decreases, but for f2 with increase in x, sometimes function increases, decreases, increases. F1 is monotonically decreasing. Yes, correct. So these are the difference between monotonically increase and decrease, right? So here 1 by c square, for every increase in the value of c, there will be decrease in sc. So that's why it is monotonically decreasing. Everyone okay? So those who are not answering, you can write in the chat also. Otherwise I will think like you are just joined and left somewhere. I don't know, maybe that's the case. Anyway, question 3. Which of the following statement is not correct about bifurcation? So who will tell me what is a bifurcation means? What is bifurcation? Yes, Soumik Pandey saying yes sir. Bifurcation, what is bifurcation? Before going into the answers, let's discuss what the concept of bifurcation is. So before that, I feel like you, I don't know what exactly you all of you are in a which level. What is a fixed point or stable point? What is it? First, let's start with that. Perturbations, the phenomenon of analyzing significant changes in output with small perturbations in parameters, changes in output. Okay, terms of bifurcation. Okay, you're going with a more general idea. In terms of fixed point, not stable point, stationary point. Sorry, stationary point. Whatever. So, Venkatrathan, what you are going in there, you are going in a more general definition, which is, I won't say it is wrong, but in terms of fixed point, can you elaborate it more? Since you are writing in chat, maybe someone else can unmute and have answer or have a discussion. What is fixed point? You don't have to go to bifurcation. What is a fixed point?
The point that is not changing.
A point that is not changing. Are you sure?
I'm going with the literal definition. Fixed point that is not changing.
Fixed point, is it
Starting-
the point that is that changes, or the system that is that changes?
The system is changing, but these changes are not affecting that point, we can say.
So if a system is at fixed point, what happens? There is new student joining. If a system is at a fixed point, okay, and you didn't do anything, no perturbation, nothing, what happens? So the mathematical definition is, suppose you have some kind of dynamical system like this, difference equation, fixed point, if like x star, if x star is a fixed point, then xn plus 1 equals xn at xn equals x star, right? This is the mathematical definition. So what does it mean physically? So if you start the system which follows this kind of equation at the fixed point, there wouldn't be any change over the generation, right? That's why it is called fixed point. So the new person who joined, so Apurva Singh, you can unmute and answer, and also you can write in the chat, okay? But please do it. So that is the definition of a fixed point. Now, do you agree, Tejinder? What is she?
Yes.
Yeah. So, and what is not a fixed point? If you start at any point other than a fixed point, it will either go to a fixed point or away from a fixed point, right? So that's what, sir, could you repeat about fixed point? So, okay, fine. So let me try to elaborate it more, since I think you need it, a lot of other people need it. Suppose a system is like this, xn plus 1 equals xn times 1 minus xn, okay? So this is your f of xn. So how do you know about what the fixed point of this system is? So you make xn plus 1 equals 0. So this gives xn equals 0 and xn equals 1, okay? So you have two fixed points, x star equal to 0, x star equals 1. These are your two fixed points. Now suppose initially you are at x star equals 0 point, like you are starting with a 0 population, so it will neither grow nor nothing will happen. How do you know? So for that, if you put f of x star will always be 0. So if you start at any of these points, x0 or x star, if you put it, see, xn plus 1 is not changing, right? So fixed point means if you start at a fixed point, your system would not be changing at all. Now if you start in some other point, suppose you started x star equals some 1.5, okay? So what happens to xn plus 1? 1.5, not x star, x equals 1.5, suppose you start xn. So 1.5 times 1 minus 1.5, which becomes minus 1.5 times 0.5. right? So you can see there is a decay of xn plus 1. So in any point in your space, in your whatever you can interpret it in any way, like concentration, species population, density, anything. If you start at that fixed point, nothing happens. If you don't start at that fixed point, the system moves towards a fixed point or away from a fixed point. Okay, Venkatnathan. Are you convinced or yeah? So that's the definition of fixed point. Now if you start at a point very close to a fixed point, suppose you start at some x which is very epsilon close to a fixed point, and you see this xn plus 1 grows or decays. Grows or decays means this is called perturbation. So if you start very close to a fixed point and the system goes back to that fixed point, then this fixed point is a stable fixed point. And if it goes away from that fixed point, then this fixed point is an unstable fixed point. Okay, any questions till this point? Anyone? No doubt, sir. Okay, like that means you don't have doubt. Okay. So fixed point. So what have we learned? We learned about fixed points and their stability, right? Fixed point and the stability. So bifurcation in principle means by changing system parameters, nature of a fixed point changes. So what are system parameters? System parameters are like, suppose we had a r here. So this is, you can interpret it as some kind of rate or probability or something. So by changing this r, you can change the nature of the system. And bifurcation is said when this nature we are talking about, if you change this r, stability of the fixed point changes or existence of fixed point changes or not. Okay, any question? So if you have to elaborate, suppose x equals x star was a stable fixed point for r equals some r0. Now you have made r equals some other r, suppose increased. Okay, so this x star has become unstable by going from r0 to r1. This stability of this x star has become unstable. So at r equal r1, so while going from r0 to r1, there will be a point, suppose rc. At that point bifurcation occurs, where a stability of the fixed point changes from a stable to unstable or unstable to stable. Or in other case, this kind of bifurcation is called transcritical, where nature of stability of the fixed point changes. Okay, sometimes you can see by changing parameters you will go from a fixed point to no fixed point. Like there will be a fixed point for some parameter and there will be no fixed point for some other parameters. So existence existence to non-existence of fixed points, it is called, anyone, what this kind of fixed points are called, bifurcations are called? The first,
Saddle node bifurcation.
yes, first kind, saddle node. So you should go through the lectures in the PPT, it is there, okay. And if around a fixed point, around a, if the system is symmetric, then pitchfork kind of bifurcations comes along. So let's, so bifurcation, concept of bifurcation is clear or not?
Yes, sir.
Okay, everyone? Okay. Okay. So what is it? Bifurcation point occurs where stability of fixed point so is not correct. Here it says is not correct. Okay. So bifurcation point occurs where stability of the fixed point, steady states, changes. Is it correct or not? Right now anyone can answer this. We have discussed it.
Yes.
Yes, it is correct.
Yes. So this question, this answer is correct. Next is saddle node bifurcation means that fixed points is a stable for all values of parameters. Correct or not? Someone else? Hold on. Show me.
Wrong.
Okay, you already said this is wrong. So this is the answer. So you can go along. Transcritical means fixed points exist for all values parameter. So I just gave you the answer. Okay. I wanted you to figure out, but I just gave it. Okay. Let's not do that always. Everyone understood this question and answers?
Yes, sir.
Shomik says yes. Someone else, just yes or no. Priyadarshini, you might be not there. Suma, if you are there, just write it. Venkatnathan there. Kalai Selvanandan, yes. Okay, fine. I'll move on. If you don't answer, it's fine, no problem. Question 4. Okay, so look at this. There are two difference equations. I am not going into details of what difference equation is, we already discussed, which are coupled. Coupled means, if you look at it carefully, you will see x's equation depends on y and y's equation depends on x, right? So these are called coupled difference equation. So what's the question is asking, the Jacobian is independent of the fixed point of xn. The fixed points of xn are real numbers. The system is stable but not asymptotically stable. The fixed points for yn are complex number. So this is to answer this question, you need to actually go through the lectures and know how to approach this kind of questions. So I will tell you. Before that, who here knows how to solve it? Maybe you can raise hand or you can unmute or anything. Who knows how to solve it? What is the approach to this kind of problems? No one knows. Yes, sir.
We need to calculate the eigenvalues to check.
Yeah, just tell me you know or you don't. Just we will discuss that in a minute. So I think Terinda knows. If you know, give a thumbs up. If you don't know, give this thing. Okay. And if you don't say anything, I don't know. I don't know what's the status. Maybe you are not here. No sir. Shomik said no sir. Venkatnathan KV is saying he knows. Someone else were interacting. Kalai Selvi Anandan. Do you know this? Like how to solve it? Like overall, like an idea. Do you have it? No sir. Fine. Vijay Lakshmi. Okay, fine. Anyway. So whenever you have, suppose let me quickly go through the method. Okay, So suppose you have x n plus 1 as a function of xn yn and yn plus 1 some other function of xn yn. So this is coupled difference equation. Okay, so what happens is quickly to check the stability, first you need to find the fixed points. So fixed points by definition are xn plus 1 equals 0, yn plus 1 equals 0. To solve these two equations, calculate x star y star. Okay, now to find out if these fixed points are stable or not, you create this Jacobian. What is this Jacobian? Jacobian is del f del xn, del f del yn, del f del g del xn, del g del yn at this x star y star. Okay, now if suppose this Jacobian here in 2 dimension, like we have two spaces, so Jacobian is a 2 by 2 matrix, so it will have two eigenvalues. Suppose lambda 1 and lambda 2 are the eigenvalues. So if real part of lambda 1 is less than 0, then for a particular x star y star, then that is a stable fixed point. Which is a x star y star is a stable fixed point. Or if real part of lambda 2 is greater than 0 for x star, then it's an unstable fixed point. Okay, so how to reach there, I am not gonna discuss that. I'll just tell you, like, you part of the system with some small epsilon and expand the perturbation in Taylor series, and you will see that in first order terms this Jacobian matrix comes along. Okay, just go through the literature. Now you will calculate, everyone has to do this. If I am saying anything wrong, correct me. Okay, like whoever knows this stuff, so 4 or 5 people knew how to do it. So first calculate the fixed points. Go ahead. You have like 5 minutes to calculate the fixed point. No, not 5 minutes. Let's give you 2 minutes. Calculate fixed points. So put, like, you have to make xn plus 1 and yn plus 1 equals 0. So for xn plus 1 equals 0, you get x minus y square plus 5 equals 0, and 2x square minus y plus 4, 2x square minus y plus 4 equals 0. No, sorry. Okay, so okay, sorry, hold on, don't do this. Actually, in difference equation cases, xn plus 1 should be equal to xn, yn plus 1 should be equal to yn. Okay, xn plus 1 equals xn, yn plus 1 equal to yn. This is the fixed point. If you write in terms of dx dt, then dx dt equal to 0 is the fixed point. But if you write as del x del t, then it's a constant term, but it doesn't change. So x square, this will be equal to x and this will be equal to y. Now you solve these two equations. Tejinder, you're saying something.
I was also pointing out that we are based on x and y.
Yes. So the point is that, like, the definition is where xn plus 1 and xn will be equal. Like in the next generation the population will be same as the previous generation. So you solve these two equations and tell me what are x star y star is, like whichever the solution is will be your x star y star. Correct? I'm saying it correct, right?
Yes.
So even if you don't know anything, whoever said that you don't know about this method, you can calculate, calculate this, right? First calculate the fixed one, right? That you should all do it. See, from this point all the questions are like you have to sit down and calculate. So I will be like, you have to calculate. So whichever answer you give me, based on that the solution will go ahead. Did you get the answer? Tejinder got it. Anyone else? So what did you get? Tell me. I think no one else is answering, or they didn't got it. Tell me, Tejinder.
For y, we are getting plus minus root 5. Since x cancels out, we can directly find from the first equation.
Okay.
And for x, we are getting x square as minus 2 plus root 5.
Minus 2
Plus root 5, one of the values, corresponding to y as plus root 5.
Okay.
The second one will change accordingly.
So
Yes.
see, this will you cancelled out x, but there could be x equal to 0 case also, right?
Yes, yes.
So you just it's like this, right? From first equation number 1, so you take x common.
Yes.
Yes. So x equal to 0 and y equal to plus minus root 5, and you put it down here and you get something like that, where you get two values of x. Okay. So let's come back. First thing, they are saying the Jacobian is independent to the fixed point of xn, which is not correct. We all know already, because Jacobian is to be calculated at x star y star, which is not correct. Second option is the fixed points of xn are real numbers. Are they? Are they real or not? The second answer depends on how you calculate. If you can calculate the fixed point, then you can answer it. The second option, are they real or not?
No.
They are not real. Why?
For this part, the earlier one also you said that x can be common, but This is not in multiplication, no? We are subtracting the values. So.
Yes, sir. I am confused here also.
No, we are only seeking cancelling x only. So the x equal to 0 is not the option.
Oh yeah, okay. I see what you are saying. So you are saying that x minus y square plus y. Okay, fine. Sorry, my mistake. Okay, if you take common, then it goes on. Okay, so x equal to 0 doesn't exist. Fine. So these two, if you get these two as answer, are they real or not? Now tell me.
No.
They are not real, right?
But sir, I think x and y are represent the mass of the species. So the negative value is it possible that y is minus root 5?
It is not. So you have to discard it. The
So if
moment you
y
the
if y is root 5, then x is plus minus, and as it is a species, so x is plus square root of root 5 minus 2.
correct
Root 5 minus 2,
correct
and y is root 5.
y is root 5, correct,
And it is obviously real since root 5 is
greater than 2.
more than 2.
Yes. So you are saying it is not real. Why? Can you tell me? Like anything is.
I was solving the other part, no? So I missed that part that y is minus root 5 is rejected.
Yes,
So I
exactly.
was so
Why?
I was saying accordingly to that.
Yeah. In general, it both are correct, but the moment you give it a context, then this doesn't exist. In a species, population, or anything, this doesn't exist. So the fixed points are real. So this will be the correct answer. Now that was what the question is. So if suppose B was not the correct answer, what will you do? System is stable but not assistable. So stability you have to check. This is also cancelled out. Last option. So stability. Just tell me the form of the Jacobian without putting the extra y star. Okay. 1 minute. You have time of 1 minute. Form of this Jacobian
In the xy form.
in the xy form only.
Okay.
I want you to do something. Just don't just sit there. Because whoever is not doing, they can refer to it later. Just take derivatives. I think you all can take derivatives. It comes out
May I
with
try, sir?
who
May I
wants to-
try?
Yeah, tell me.
It is lambda square plus 8xy minus 1 equal to 0. It's come from me.
I don't get what lambda is first of all. Tell me one
Lambda,
minute.
it is the characteristic equation, so it must be one lambda
Okay,
arise.
tell me the whole whatever you said.
Lambda square plus 8xy
Huh?
minus 1 equal to 0.
So there should be one more lambda somewhere, right? Or is it there is no lambda?
It is the characteristic polynomial, not the Jacobian. And the Jacobian,
Yeah, I understand, but there is no lambda here in this term, first order term. Let me check. It is 1 minus 2y.
because there are two factors. One is 1 minus lambda and one is 1 plus lambda. So it is 1 square minus lambda square.
4x.
And 1 minus arise, so it is lambda square minus 1.
So this is the Jacobian or not?
Yes.
So 1 minus lambda minus 2y 4x minus 1 minus lambda. Okay, then you get this lambda square minus 1 plus 8xy. Okay, there is no first order in lambda, then it is easier to solve. Now rest you know what to do. Okay. Rest you know, like calculate this lambda at this x star y star and see if it is real or not, and go with this. What did I write it? Like stability, yeah, real part of lambda. Okay. Anyway, for this question number 4, you got this B answer. Fine. Shall I move on?
Yes, sir. You can move on.
Okay. Which of the following statement is not correct about nonlinear cell division model like this, where SC is the survival function? So idealized contest competition, you already discussed it once. You should be able to answer this right now. Idealized contest competition exhibits exact compensation for large population size. Is it correct or not? What is exact compensation means? The next question is, next two questions are like this only. So remember, this question says which is not correct. So what is exact compensation? See, exact compensation means exactly one resource is used exactly by one cell. Hence the cells which didn't get any resource will not survive. Or exact compensation means all the resources are distributed among all cells equally.
The second one.
This second one. And can you please elaborate a little bit?
Whatever resources are being consumed are again provided in the same effect.
Okay. In the cells, so like exactly one resource is used by exactly one cell. Like there is a mapping, you're saying. Or in scramble competition, what is like whatever resource is there. Suppose this is resource. Like suppose these are the resources. Okay. Let me try to get this kind. These are the individuals. So in scramble, it will be if every species will have the all of them, access to all of them, right? This is scramble. Correct or not? Am I saying it wrong? Then point it out. Huh? No one says anything. Okay, the first question, let me go back. I removed everything. Okay, fine. So scramble means in the someone was writing something. Do you remember what was written in the text for C less than C critical? For zero,
Less than equal to.
C less than C critical. Is it scramble?
Yes.
And what was contest? Right, it was contest.
Yes.
So what happens is whenever C becomes greater than C critical, like if this resource is enough, C critical is enough, so everyone has the same survival function. But if the resource is not enough, like there are more population than there are food, then there will be a contest starting. So if not everyone can access to the all the resource available, there will be sharing. Sharing means competition, where not everyone will get the equal opportunity to have their resource. So exact compensation means exactly one resource is used by exactly one cell. Hence the cells which didn't get any resource will not survive. This is the correct or not? This option is correct or not? Like this option is answer or not? I'm saying which is not correct. So is it correct or not?
No.
No. Yes. Because there will be sharing. like lower number of resource, higher number of species. Okay. Fine or confusion? Let's exclude. Exact competition means all resources are distributed among all cells equally. Yes, that is exact competition, compensation. And scramble is correct and first option is correct. So B will be the wrong answer. Okay, since anyone not saying anything, I assume, okay, she said give a thumbs up. Okay. Next, given a nonlinear discrete model, something where A, B are some parameter, the condition for fast bifurcation to occur is, yeah, now again you have to know how to do it. Who knows how to do it? Who knows? No one knows. Did you see the what to call the PPT? There are some formulas are written. Anyone remember? Okay, let me write a few down. Then, like for saddle node, it is f of yc mu c equals 0, fy of yc mu c equals 1. Do you remember this stuff? No sir, no, this is I think old answer. Kalas LV Anandan. So tell me, what is this f in this question? What is this f? In these questions, like how do you find this f? Show me.
The right hand side.
The right hand side, exactly. So for this question, the f will be R, S, A, B. There are 4 control parameters. Okay. Now, for the bifurcation to happen, you have to check this stuff. Here, YC is, like if f was a function of y, then YC is the fixed point and mu is the bifurcation point. So you have to find the fixed point first. So can you find the fixed point? For this equation, try finding, excuse me, hello, are you doing it?
May I say, sir?
Mm-hmm.
May I?
Yeah, tell me.
One is 0 and another is r to the power 1 by b minus 1 by a. 6 points.
Like this? Yeah.
Yeah.
Something like this will happen.
Mm-hmm.
Now you have to check these conditions. That what point, like at so this is actually your yc. Now if you find out this form, there are more like f of mu. So f of y means del f del y. Okay. So if you calculate this and put this yc and find out at what mu value there is a bifurcation happening. Okay, so that will be a calculation heavy task, but you get what uh, how to do it, right? Yes or no?
Yes, sir.
Everyone? Tejinder, you have question? Any question?
I am still not sure
Okay.
how to go about further.
So you go. You remember this conditions for bifurcations to occur at.
Yes.
Hmm. So you have to use those.
Okay.
So go through that. You put this. You get to the equations, take derivatives, put these values. Mostly lambda equals 0 value. You check for lambda equal to 0 only. Then you will get some idea about what this kind of equations will come. So probably
Okay.
this was the answer. I am not exactly sure. You have to calculate. Okay. Just check.
Okay.
Okay. Fine. I'm not gonna do the whole calculation again. I'll be moving on to the next question. Again, there is predator prey model. So you have idea about what predator prey model is? These models are very famous.
Yes.
Yeah.
Yes.
So predator prey model is when there is a predator, there is a prey. So predator predates the prey, like eats up the prey's population, and prey can reproduce. This kind of model. So you see, xn plus 1 is proportional to xn, that is the birth rate, and there is a death. You can say x squared in form x square, and then it reduces with proportional to the population of y. So y is the predator for the prey, which is x. So you don't have to know all of this to actually calculate it. So how to calculate? It is the same again. So the question is that the equation for predator prey for predator has logistic growth function, while prey has geometric or exponential growth. Now tell me what are these two terms means? What is logistic growth and what is geometric or exponential growth? What is logistic growth? Um, who can answer? Shall I point out anyone? Kirtika, do you know what is logistic growth is? Soumik, do you know?
When the death rate is also included in the birth rate, then the total birth minus death, uh, this constant is proportional to the species mass. This kind of a.
Like suppose xn plus 1 equals xn is it what is this? there
This
is
is this is now this is logistic, bro.
now this is logistic. What was it before?
It is linear, bro.
Linear growth. And but why it is logistic? So if this xn is less than 1, then x plus n plus 1 is positive. The moment xn goes above 1, this x plus n plus 1 becomes negative. So there is a some kind of cutoff happening. So
Yes,
below
it is
the
called the
cutoff,
carrying capacity. Yes, I remember it.
yes,
Carrying capacity.
carrying capacity, and there is this r. Do you know what this r is? This is called rate,
Growth rate.
growth rate. So depending on this rate, the system behaves very differently. So did you go through this? This is a very interesting problem, this logistic map, logistic growth problem. So where based on this r, you can see there's like, if you look for the bifurcation based on r, you can see decay, saturation, or some kind of, do you know what this is? This kind of graph have you seen?
Bifurcation
Yeah,
phenomena.
the whole thing is bifurcation diagram based on r. So around r equals 3.5, this whole bifurcation diagram shows a lot of multiple bifurcations, and this system is called chaotic system. This is a chaos for r greater than 3.5. So go through these are very interesting problems. I think in the lectures he has covered this. I don't know in week 2 or next week, I don't know. Do you anyone know? He covered this in week 2 or week 3?
Covered week 3, but still completed only week 1.
Okay. So this chaos system happens in logistic growth. So I don't go into details of chaotic systems and all. So this is logistic. And what is exponential? Exponential growth refers to a huge rate in growth. Yes, true. But what is like if you want to write an huge increasing rate? Yes, that's called exponential, correct. But what if you want to write a equation? What will be the equation? It's easy, just think about it. E to the power x is used in yes, it is e to the power x will come out as a solution. Or graphing the function or graphing is below. Yes, all of these are correct, but the exact solution will be is some kind of this kind of thing. That will be exponential. What is the solution of this kind of equation? Dx dt equals x. What is the solution? E to the power t, right? So with time x grows exponentially. So this is the form of differential equation. What if you want to write in a difference equation form? Just same xn plus 1 equal minus xn equals xn with some alpha. So xn plus 1 equals 1 plus a or alpha xn. So this is exponential growth. So the first this is understood or not?
Yes.
Yes.
Yes. So the equation for predator has logistic growth. So predator is y. Is it logistic?
No, sir.
No, right? Because it has to be of the population times 1 minus population. So correct statement they want consider. So this is wrong. So one can make a model with logistic growth rate for predator and prey both. Is it correct? This is a very interesting option. One can make a model with logistic growth rate for predator and prey both. Is it possible to have a real system where both predator and prey are logistic? So I think it is not. Why? I'll tell you. Because suppose prey is growing logistically, so towards the carrying capacity, if it reaches to near the carrying capacity, in case suppose this is 1, but you have to remember predator is also trying to reduce it, so you wouldn't get anything like only any population which only depends on its own population. If it is predator and prey model, the predator will have some effect here also, right? Suppose x n plus 1 equals some r xn 1 minus xn, and y n plus 1 equals some r y. So people are coming joining here this time also. Okay, r some r2 yn plus 1 minus yn. Now what will happen is towards the end, if the prey population increases, the predator will try to decrease it, sir. Yes, sir. Venkatrathan said yes. Like in what answer you are saying yes? So my point is, if you write both are growing logistically, then if prey grows logistically, then with the effect of predator, prey will decrease. Now if the prey decreases, the predator doesn't have enough food, so the predator will start to decrease again. So both simultaneously existing in a logistic growth may be not very realistic. That's what I'm trying to say.
Yes, sir. It is not realistic, but in some situation it may be possible.
Some situation it may be possible. True. So B could be the answer. Let's check for C. So C says A equal to B equal to C equal to D equal to beta. The model is stable but not arithmetically stable. Now they are questioning about stability. So what will you do? How do you check stability again?
We have to check the stability by putting these values alpha, A, B, C, D.
Before
or
that,
beta.
you have to calculate the fixed points.
Hmm.
So how
Fixed
right now you know the fixed points. So whenever you have to calculate stability for a two species like system, what will you do? Same process. Calculate
Jacobian.
fixed point.
Jacobian and the
Yes.
characteristic roots.
Yes. Equal to 0. From there calculate lambda and stability. Okay. So you have to calculate this. I will not give you the answer. Maybe B will be the correct answer, or if you see that C is coming out to be the correct answer, then both can be correct answer, not no problem. So say the stability of the given model independent of the value of the parameter of b. It could be possible, right? There could be some parameters which is not affecting the stability of the fixed points. Maybe in this characteristics equation, in the eigenvalue there is no b. So this all of the three are possible correct answer unless you calculate it, right? So again I will not calculate the whole thing because it is very easy calculation and I want you to go through the calculations. Okay.
Yes, sir.
Okay, just check. C could be the correct answer. Just check. Anything? Any questions? Okay, fine. Let's go to the question 8. Let the discrete time model given by this and mark the correct statement. So there are two fixed points equal to 0, trivial, equal to k minus 1. So just calculate the fixed point and tell me what is the fixed point. Everyone. Venkatanathan, are you calculating? Yes. Okay. Good. Very good. Anyone else? Suma, I don't know. She is calculating or not. Anusha, I think just joined or something. Please calculate the fixed point and tell me what are the fixed point.
K by R into R plus 1. And 0.
What did you get? Did you get K or am I doing it wrong? I'm getting C equal to 0 and C equal to K. You said something with R.
Sorry, sir. I have got some mistake.
Okay. So is it my calculation is correct? Anyone can confirm?
Yes, sir.
Okay. So this cancels out, right? C equal to 0 is correct, but C equal to K minus 1 is not correct. Both fixed points are unstable independent of the value of R. How do you calculate this? So again same, but there is, right now there is no Jacobian. So you take this kind of stuff. F of C equals C into 1 plus R 1 minus C by K. You do F prime and put C equal to 0 ones, C equal to K ones, and check if it is stable or not. If it is less than 0, then it is stable. If it is not less than 0, then it is unstable. Are you doing the calculation? Take derivative, put it. So I got these two values of f prime. No one is saying anything. Tejinder, are you doing?
Yes, sir.
So did I get it correct?
I think the second one is 1 minus r
1 minus r.
plus. I'll check again.
C plus CRC.
1 plus r minus 2r.
Oh yeah, there is one r. Sorry, I missed out one r. So this is 1 minus r. Correct, you are correct. Yeah. So what's happening? See, second option says both the fixed points are unstable independent of the value of r. So you can see this f prime depends on r. So second one cancels. Now you have to check among these two where f prime is positive or negative. So for r less than 2, for r, see, you have to check 1 less than r less than 2, this limit. So if r greater than 1, this is always greater than 0, so this is unstable, right?